disjoint, disjoint, disjoint set, disjoint set, disjoint set. This is a direct opposite of what? Equal set. This is a direct opposite of what? Equal set. Yes, the direct opposite of equal set. The direct opposite of what? Equal set. And it is defined as a set. It's defined as a set. Defined. It is defined as a set in which the elements present in the first set, the elements present in the what? The first set are not in the what? Second set. Are not in the what? Second set. Set are not in the what? Second set. And right, and the number of elements in the first set, the number of elements in the first set is not the same thing as the number of elements in the second set. In the second set, number of elements in the first set is not the same thing as the number of elements in the what? Second set. Are you following? Number of elements in the what? Second set. Full stop. Full stop. Full stop. So majorly these are the four types of what? You might see another textbook that say we have finite and infinite sets. No, these are the major four that you need to understand. Equal set, disjoint set, empty set, and what? Singleton or unit set. Full stop. So after you understand that, the next thing for you to now understand is subheading. Right, subheading. Yes. Like paragraph or anyone. Yes. So you need to understand the following. They are not types of sets. Please note them. They are not types of sets. You need to understand what we call. Let me start with power sets. Power sets. You need to understand what we mean by what? Power set, subsets. These are not, they are not what type of sets, but they are just what? They are just terms that you need to what? Understand. So we have power set, we have subset, we have power set, subset, we have union set, union what? Set, and we have intersection. Or let me do it like this. You have superset. Let me take you through the three first. So write these three first, then underline them. Because if you don't actually understand power sets, you get, there's no how you want to understand subsets. And if you don't understand subsets, you cannot understand what? Supersets. You get? So let's start. Power sets. Power sets. This can be divided. This can be divided as the number of derivatives derivatives, as the number of derivatives, as the number of what? Derivatives a set comprises. As the number of derivatives a set what? Comprises. Full stop. As the number of derivatives a set what? Comprises. Full stop. Power set is denoted as P and is given by 2 raised to the power of n. Power set is denoted as what? P and is denoted as what? 2 raised to the power n. 2 raised to the power n. 2 raised to the power n. Full stop. So, what do you mean by this? Let's say, okay, let me use mama as an example, or beans as an example. You know, in beans now, you can see normal, you can see mama there, you can see akara there, another thing you can see baby, thank you, and you can also see other things. These other things that you can see are what? Derivatives. But what do you mean by power set itself? The power set is telling you that all these things that you can see, just tell us in number. Like, okay, in it I can see beans itself, Abi. I can see beans itself. I can see, because in beans I can put beans, Abi. So I can see baby, I can see mama, I can see what? Akara. What again? Ekuru, thank you. You can see 5 things. You get? So we have 5 things like this that you can see. So that 5 that you see is what we call the power set. But now listing it out, all the things that you can see, like, okay, you can see beans, you can see mama, all those things that you are listing them out, you understand, is subsets. You get? But okay, everything in total that you will see, what is the number? That's the meaning of what? Power set. So if you know the total thing you want to see, let's say, okay, I will see 5 things in beans. They can now ask you, okay, list them. So listing them out is what? Subsets. Are you following? So now let's say we are given a particular set, set A equals to 1, 2, 3. So, and they ask you how many. They will not say how many power sets. In fact, they just say how many subsets will you see. Well, nobody will ask you what is the power set of the particular set. No. But they expect you that before you can know the subsets, you must have understood what? Power sets. So, what's the power set for this one now? 2 raised to the power n, Abi. So, n is the number of elements. You get? So, how many elements do you have here? 3. So it just be 2 raised to the power what? 3. 2 raised to the power 3 is what? 8. That means the total thing you can see in this particular set is what? 8. Do you understand? So if we now ask you to list them out, that's where what? Where subset comes in. I follow. So how do you now list out? Because if you want to, there is no how you want to do. You see subsets in question. They will ask you to list the subset of a particular set. You can't go with that. So how do you now list subsets? We have rules for that. Normally, subset means that, okay, what you can see that we can get from a particular thing, that's the meaning of subset. But sometimes in mathematics there are some rules that will deviate more from general rules and regulations. You get what I'm saying? Now, you've understood the meaning of power set. So anytime you have to calculate power set, you know what to do, right? Let's now move to subsets. So, right, subsets. Subset. This deals with listing. That is lists. Listing out the item The items or the derivatives. The items or derivatives of a particular set. Listing out the what? The items or derivatives of what? Particular set. Full stop. It is to be noted that, continue. So you have to note this thing. You want to list out subsets. It is to be noted that for a single set, empty set is a subset of every set. That's number one thing you need to know. We are dealing with single set like this. A equals to 1, 2, 3. 1, 2, 3. Empty set is a subset of what? Every set. So I write A equals to 1, 2, 3. Empty set is a subset of what? Every set. Comma. The set in question is a subset of itself. The set in question is a subset of itself. Are you getting it? It's a subset of itself. So for a single set like this, if you are dealing with single sets, it's always